All right, let's now consider an interesting exercise for you. And let me pose the question first before I try to solve them together with you. Let me pose the question right now on the slides. Do these two programs behave the same at the runtime? So this is one program over here, okay? It might be printing out I is larger than or equal to 3, or it might be printing out I is less than or equal to 8. This is just second program. Apparently you can see this one, well, I can tell you that the only difference between the two is here you got an extra else, which is completely valid syntactically, all right? And you should really tell yourself that this is a single if statement. This is like a two independent if statement, right? That's something we talked about already. That's question number one. Do they behave the same at the runtime? Meaning that given any inputs, are they going to print out the same output? That's the question, right? You can pause the video and think about it. Okay, I'm going to post the second question as well. Okay, so two questions in total. Question number two. Again, consider another two programs over here. The first program, we still got different ranges over here, different intervals. Less than or equal to 3, larger than or equal to 8. The second one over here, basically exactly the same, except that we actually got if as opposed to else if, right? So these are very important two questions. I would suggest you think about it before you actually hear my discussion, right? All right. Assuming that you already paused the video and thought about it, okay, let me tell you this. The essence of solving this problem over here is to consider whether the branching conditions over here, this is the first pair, and this is the second pair. Are they overlapping or are they disjoint? That's the critical question we want to answer. Let me illustrate what I meant over here. Let me switch to iPad over here. So now I'm listing exactly the two pairs of branching conditions. So these two are the two intervals for the first example, the first question. And these are the two branching conditions for the second question. And we talk about overlapping or non-overlapping. Okay. So when I say overlapping intervals, I really mean there might be one value that actually belongs to both intervals at the same time. When you say non-overlapping, that means there's no value that actually belongs to the two intervals at the same time. Let's see exactly what I meant. Let's try to visualize this, but this might be the most effective way for you to understand. Okay, let's try the first one. Larger than or equal to 3. Over here, larger than or equal to 3, all the way to plus infinity, conceptually. And then the second one, less than or equal to 8. Less than or equal to 8. You can see apparently there will be some value that can belong to these two intervals at the same time. For example, the value 5 over here, you can see 5 is going to satisfy this and also this simultaneously, right? So you can say these two intervals are overlapping. Of course, this is only one example I'm giving to you. Given any arbitrary intervals, now this is how you actually decide or determine if they're overlapping or not. All right, let's see the second pair over here. Let's try I less than or equal to 3, and also I larger than or equal to 8. Let's try less than or okay. Let me do it. Put it this way: less than or equal to 3 over here, and also larger than or equal to 8. Is it possible to really find a value that is going to satisfy this and this simultaneously? The answer is no. For example, if I choose some value over here, for example, if I choose 9, 9 satisfies this, but it does not satisfy that. And over here, if I choose 2, 2 satisfies this, but does not satisfy that. So I would say these two intervals or ranges are non-overlapping. All right, having agreed on this, let's now return to our two examples over here. Okay, let me just go over one by one together with you so we can answer the two questions. All right, the first question over here, the essence for this question, there are two dimensions over here. The first dimension is you want to consider single if statements versus multiple if statements. That's the first dimension. And the second dimension is whether or not the intervals for their branching conditions are overlapping, right? So there are two dimensions. Let me write it down. First dimension is single if statements versus multiple. Second dimension is overlapping or not. That's really what I'm trying to illustrate for this part of the lecture. All right, so these are the two. single versus multiple, and also overlapping or not. All right, so now the two intervals we're considering right now, larger than or equal to 3, and also less than or equal to 8, we already know they actually overlap, right? That's exactly this interval over here. All right, so this is overlapping one. And let me just put it down to say they are really the same over here. All right, so now we want to know whether they will behave the same. The answer is no, actually, because if somehow I choose a value that actually is going to satisfy both intervals over here, for example, I'm going to choose the value 5, right? That's what I would do. Okay, so now if I simply choose the value 5, okay, just 5 over here. If I choose that, what's going to happen is they are going to behave differently if the branching conditions are overlapping between single if statements versus multiple if statement. Can you see why? Before I start illustrating, okay, let me illustrate this. Hopefully you know the answer. Let's try 5 over here, right? So now if I is larger than or equal to 3, so 5 larger than or equal to 3 is actually true, right? So that means I'm going to execute this. And for the semantics for a single if statements, after the first satisfying branch is executed, I'm going to bypass the rest. So I'm not going to execute I is less than or equal to 8. So I'm simply going to print out I is larger than or equal to 3. So that'll be the output. Okay. Hopefully you can see that, right? What about the second case? The second case over here, let me try 5 over here. If I try that, 5 larger than or equal to 3 is going to be true. So I'm going to output this for sure. I is larger than or equal to 3. And then I'm done with this particular if statement. But this if statement here is an independent one. It does not belong to this first one. So they're completely independent, right? So now remember these two. So these two are independents. If statements, which means I'm still going to check for this condition over here. So now 5 less than or equal to 8 also is satisfied, right? Because these two actually overlap, as we said. So I'm also going to execute this as well. So I is less than or equal to 8. So that's the answer to the first question, right? Remember the first question over here, do these two programs actually behave the same at the runtime? No, they do not, because the branching condition over here are overlapping. If I choose a value, for example 5, that will satisfy both conditions, in the case of the single if statements, it's only going to execute the first satisfying branch. And for the multiple if statements, it's going to execute both independently, right? So they behave differently. Okay, that's the first question. What about the second question over here? Well, we already argued that these two intervals or these two conditions are non-overlapping or disjoint. In that case, what's going to happen over here, right? Let's now switch to the second question over here. All right, so now this is second question here. So now it is simply not possible to find a value that is going to satisfy both this condition over here and also this condition over here. It's simply just not possible, right? So either you will satisfy this or you will satisfy that, or you simply don't satisfy any of them, right? So let me just visually speaking, either you choose a value that's here, you choose a value that satisfies the green constraint, or simply choose a value that does not satisfy either, right? So let's just try one example over here. Example will be, let's try the one that's going to satisfy the green. Let's say 2. Let's say for both of them, right? You can argue similarly for other values as well, but I'll just do one together with you. Let's say it's 2. 2 less than or equal to 3 is going to be true. So that means I'm going to execute this line over here. So it's going to be I is less than or equal to 3. And then I'm going to bypass. Okay. So now notice the execution path. The execution path really is, I will actually check this condition over here, which is true. And then I'm going to execute this. And then the rest is simply bypass. Notice that I actually didn't check this particular condition over here, right? So notice the pink one over here is really the execution path. Let's see the second one. The second one over here, I'm still, let me use 2 over here. And then let me just wipe it out over here. Just so you can see that. All right, so for the second one, 2, first of all, check this first independent if 2 less than or equal to 3 is going to be true. So I will execute this for sure. Okay, so I is less than or equal to 3. So far, the same. And then I'm still going to check the branching condition for this second independent if. However, 2 larger than or equal to a is going to be false. So that means I'm going to bypass the body over here. So now let's take a look at the execution path. So I'm going to check this first branching condition, which is true. I'm going to execute this. And now I still need to check this branching condition here. But turns out it will be false, so I wouldn't execute this at all. So you can see the execution path between the two are not exactly the same, but the outcome is really the same. You can see the outcome is really this and this identical. However, for the execution path, for the independent if version over here, you also need to check this particular condition, even though it will turn out to be false, right? That's the subtle difference. So internally, for the internal working for the program, it's slightly different. But the question was really about whether they behave the same at the runtime, about the external output. So the external output will just be the same. All right, so that's about these two questions over here. I hope it's not too challenging, but the important thing is to learn about that, to learn about the notion about either overlapping or non-overlapping, or sometimes we simply say disjoint. They are synonymous. Disjoint. All right, let's now do some very some exercises. Okay, let's go to the slides over here. Okay, so these are the two that we just spoke about. You can just read the slides, but everything has been said already, right? I'm not skipping anything. All right, let's do, okay, this is a common error over here. For example, if you take a look at this. So what's wrong with this? First of all, how many if statements do we have over here? Do we have a single if statements or do we have multiple if statements? All right, hopefully you agree we actually got multiple if statements, number one. Number two, if we got multiple if statements here, do we have overlapping branching conditions or do we have disjoint branching conditions? According to what we learned, so these conditions are overlapping. So this program here is actually erroneous, is actually wrong. All right, let's see why. Let's now switch to over here. Okay, basically this is actually wrong. Let's first of all see how many if statements do we have over here. So this is the first if statements over here. This is the first one. And then, so this is the second if statements. And this is the third if statement. Itself includes the optional else. So we got 3 if statements here. Okay, so 3 if statements. First of all. And this will be the correct version. You can see this one actually got just a single if statement. A single if statement. Well, we know already, in case you got single if statements versus multiple if statements, if the branching conditions is, as you can see, larger than or equal to 80 is the green. And also larger than or equal to 70 is the orange. And larger than or equal to 60 is the pink. They actually overlap. That means they're going to behave differently. This and this is going to behave differently. How so? Let's see this. Let me write it down right away. So this is actually the correct version. However, this is actually the incorrect version. Let's see why. Let's now try to trace them together using the same input. Let me use 84 over here, right? If I use 84. Why don't we try the correct version? So now 84, if I'm going to execute this, 84 larger than or equal to 80 is actually true, right? So now that means I'm going to execute this right away. You're going to print out A over here. So the execution path is simply checking the branching condition. That'll be the first satisfying one, and then execute this. And then the rest will just be bypassed. The rest will just be bypassed if I use 84. All right? So that'll be the first case. What about the incorrect case, where we got multiple if statements? In that case, let's say we still use 84. So now check the first if. 84 larger than or equal to 80 is true, which means we're gonna print it out. We're gonna print out A. And then we're still going to check the independent if. We don't bypass that because it's independence. So now 84 larger than or equal to 70 is also true. So that means we're also going to print this out. Hopefully you see what I'm doing here. And then we're also going to check this independent if. So now 84 larger than or equal to 60 is also true. So that means we're also going to print out this particular condition over here, right? So that means we'll also print out B and C, right? So it turns out we'll actually get A, B, and C printed out to the console. A student cannot get more than 1 letter grades for sure. It should be just A. And if you actually use the correct version over here, it's just going to, this correct version over here, it's just going to print out A without any further, right? Because it will simply bypass the rest. All right, so let's see what the execution path is. And by the way, if you see that, once we execute this branch over here, we're going to bypass the else part for sure, right? It belongs to the if. The execution path is going to be something like this. We check this, which is true, we execute this. We check this, which is true, and then we execute this. And then we check this, which is true, we execute this, right? So that's the execution path. You want to compare 1, 2, 3, 4, 5, 6 versus just 1, 2. Okay, so that's a correct versus incorrect. It's a common error. You want to make sure you have to use a single if statements over here if somehow the conditions are overlapping, most likely. So that's a common error unless you really know what you're doing. Okay, and then if you got overlapping conditions and also with the multiple if statements, so that simply means you're going to execute. It's very possible to have a value that's going to enable you to execute every statements over here, right? So that's in this particular example, you can see there's a common error, right? Because you just cannot have more than 1 letter grades. All right, let's now just finish this part just by going over just a few more examples together with you. Okay, let's now go back to the slides. So that's the one I just talked about. All right. So let's now see this. Basically, let's do some exercise over here. Consider, you can see multiple if statement over here, multiple, right? And now, does this program always print exactly 1 line? Would it? Well, basically, how do you judge? You will only print out 1 line if the branching conditions are disjoint. If they are disjoint, that means exactly one of them will be satisfied. But now, are they disjoint? Right, let's go back here. Okay, you can very easily see, right? We already talked about in the previous part of the lecture how you can visualize that. But now here you can simply see either x is going to be less than 0, okay, over here. And then also between 0 and also 10. 0 and also strictly less than 10. And also we got this part over here is going to be between 10 and also 20. So between 10 and also 20. Okay. And finally, we also got this one here, larger than or equal to 20, strictly, yeah, over here, right? So that they are not overlapping all the conditions. It's really important to notice that, right? So you can see all these branching conditions over here, they are disjoint. Meaning that no value can satisfy more than one of them. And what's the consequence of that? So the consequence of that is no value can really satisfy more than one of them. You can see they actually cover the entire number line over here. So that means any value is going to satisfy exactly one of them, right? So now that means only one branch, only one statements, only one if statements body of code is executed. Let's just see one example very quickly, right? If I say, for example, if I choose a value that's over here, let's say 5. What if I choose 5? If I choose 5 over here, 5 less than 0 is going to be false. 5 less than 0 is going to be false. In that case, I'm going to bypass over here, right? And then 5 is between 0 and 10 over here, so it's going to be true. So that means I'm going to execute this for sure. What about the rest? I'm also going to check this. So is 5 between 10 and also 20? 5 definitely does not belong to this range over here, so I'm going to bypass this. I'm also going to check this particular independent if statement over here. 5 larger than or equal to 20 is also false, right? The previous one is also false. So that means I'm also going to bypass this one over here. You can see in this case, we are only going to execute just this in the case of 5. All right, guys, I hope that makes sense, right? Just one simple exercise for you to see. If you got multiple if statements and then the branching conditions are simply disjoint, so that means exactly one branch will be executed. Okay, let's now see the second exercise. All right, you can see exactly what I just said. Okay, what about this one over here? Well, this one, the same idea over here. You can see basically now the only the same destroying branching conditions we actually put over here, the same. Okay, the same. However, we just say else if, else if, else if. So now, are they always going to print exactly one line? The answer is yes. Okay, so now let's look at that. So if you can just focus on just this part over here, just this part. Okay, so overlapping. So the all of these conditions are non-overlapping and they're disjoint. First of all, we know from the previous one. Okay, however, if you have a single if statement over here, it's a single if statement, right? If you have just a single if statement, in some way, it doesn't really matter if the conditions are overlapping or not. You always just execute exactly one branch, right? Single if statements. So that means exactly one branch, right? That's the semantics we talked about last week. Exactly one branch is executed, despite the fact that whether this is actually overlapping or not. Okay, but let's say in this case over here. So now the question is, does it always print out exactly one line? Yes. So either you satisfy this, in which case bypass the rest, or you don't satisfy that and then you satisfy this and then you bypass the other two, or you don't satisfy this, you don't satisfy that, and then you satisfy this, you bypass this, or you don't satisfy this, you don't satisfy this, you don't satisfy this, and then you satisfy that, and then go to the next line of the code if there's any. All right, so that's about this particular code, right? So now again, let me emphasize. The answer is yes. You will always print out exactly one line. However, the reason is this is a single if statement over here. So that's why after the first satisfying branch is executed, you will simply bypass the rest. It's different from if you got independent if statement, right? That's the point I'm trying to emphasize over here. So we have emphasized this many times. All right. Okay, so that's about exactly what I just said. You can also read it over. All right. So now, finally, I want to illustrate this point over here, right? In some way, it's really unnecessary if you're really using if, else if, and else if, and else if over here. You don't really have to write this in order to make sure all the conditions are disjoint or non-overlapping. For a single if statements, even if the branching conditions are overlapping, you can still get the same result. You can still get a correct result. Okay, let's see why. Okay, I'm gonna do some reasoning over here for you. Okay, so now I just want to talk about this. You can see, for example, you can see the only difference between compare this version over here, we're using a single if statements, and also compare this simplified version over here, where we also got a single if statement. That part is the same. The only difference is you can see this part seems to be simplified from these two. However, we want to see why it's actually equivalence, right? You want to use the knowledge we actually learned before very quickly, right? So now you can see if we are able to get to over here, get to else if. So what does that mean? So that means this part over here must be false. Otherwise, we wouldn't get there, right? So that means it is not the case that x less than 0. And then if this is also true, and then we're going to execute this. Agree? And also x less than 10, if that's also true, so that will be the condition under which we're going to execute this. So now let's simplify this. Remember logical law for negation. So x larger than or equal to 0 and also x less than 10. So now take a look. This part over here is exactly the same as x larger than or equal to 0. So that part there, in this case, you don't really have to put it explicitly, because in the case of else if, because of the way we actually execute the single if statement at the runtime, meaning that only the first satisfying branch will be executed. If you are able to reach this point over here, that means all the previous branching conditions are simply false. All right. So this combined with the implicit one over here is really equivalent to this condition over here. That's my point. Let's take a look at one more. Okay, you can really see my point over here. Let's see this one here. When will we execute this particular line over here? Well, not only that x should be less than 20, but also you can see this one must be false. And also this one must be false as well. This one must be false. And also this one over here must be false as well. So that means not the case x less than 0, and also not the case x less than 10, and also x less than 20, right? So what would that be? Well, apply logical law, larger than or equal to 0, and also x larger than or equal to 10, and also x less than 20, right? So now you can easily visualize to see this part over here can be simplified further. You can see this part over here, larger than or equal to 0 and larger than or equal to 10. You can see this part here can simply be crossed out, because they are simply just so in some way well, if you so try to visualize that, right? If you look at that, sorry, let me be precise over here. One is larger than or equal to 0, another one is larger than or equal to 10, and then if you take the intersection, it's going to be larger than or equal to 10, right? So that's why this can be simplified into x larger than or equal to 10. And now take a look. Larger than or equal to 10, also larger than or equal to 10. So they're equivalent. All right. So guys, I think you might just have been using that anyway, but I think you may not have thought about why these two are just equivalents, right? So that's why I want to explain it to you. All right. So now, so in this part of the video, we actually talk about quite many examples about again, two dimensions. First dimension, single if statements versus multiple if statements. Second dimension, overlapping conditions versus destroying conditions. Study these two dimensions and go over the examples again. Hopefully that will make sense to you.